Okay, so let's finally put this all together, right? So what I'll be wanting to do again is want you guys to graph one cycle and clearly let me know where all the good data points are, all the extrema, intercepts if we can find them. And if you just follow what I'm telling you, it's going to be it's going to happen automatically. So the first thing we're going to do is identify who's who here. So right here, A is equal to 4, right? And C is equal to 3. So this tells us that our amplitude is 4 and that our equilibrium, right, is occurring at y equals to 3. So we can already start putting the graph together a little bit just with that information. Again, this is all the stuff that impacts our y coordinate. In terms of our x coordinate, b is equal to 2, and it looks like d is pi over 2. So what does this tell us? Well, this part here tells us what our new period is, right? It's 2 pi over 2, which is pi. And since we're subtracting pi over 2, this means we're moving over to the right pi over 2. All right? And then when we're going to get ready to manipulate the data, the multiplications and divisions happen first, and additions and subtractions happen next. So we're going to go to our data, right? On a cosine graph, our basic data is 0 and 1, pi over 2 and 0, pi and -1, 3 pi over 2 and 0, and then we get 2 pi and 1. So handling the multiplication and divisions first, let me change colors here. Right here we're going to be multiplying all my y values by 4, and here we got to divide everything by 2. Well, dividing by 2 is the same thing as multiplying by a half. So when I do the a and the b part, right, let's do the y first. My new y values are going to be 4 and 0, -4, 0, and 4. My x values, well, half times 0 is still 0. 1/2 times pi over 2 is pi over 4. That's going to give us a pi over 2, a 3 pi over 4, and a pi. So you can see physically, right, we went from a interval of action from 0 to 2 pi period to a 0 to pi. So that matches what we said in the new period. And we've just handled a and b as far as our manipulated points. So now we got to add 3, right? Since we're shifting up, we're going to add 3 to all of my y values. And since we're shifting right, I've got to add pi over 2 to all my x values. So how about, let's do some math over here. So my new data points, I'll bring them down here. Let's do the easy ones. 4 plus 3 is 7. 0 plus 3 is 3. -4 plus 3 is -1. 0 plus 3 is 3. And 4 plus 3 gives us 7. The tougher ones, well, 0 plus pi over 2 is pi over 2. Pi over 4 plus pi over 2, well, getting a common denominator, this would be 3 pi over 4. Adding it to pi over 2, pi over 2 plus pi over 2 is just pi. Right? 3 pi over 4. If I add that phase shift, we're looking at 3 pi over 4 plus 2 pi over 4. So that's going to give us 5 pi over 4. And then if we add that to pi, we get 3 pi over 2, right? Because that's just 2. All right? So there's our phase shift. And so what I now have, right, there's all the important data pieces for our new function. So I can go to my grid, right, and I'll just kind of write something out here. Along my y-axis, right, we're up to 7 and -1. So perhaps, how about I just do that in steps of 1, right? So there's -1, 1, 2, 3, 4, 5, 6, and 7. So there's 7, 1, 2, 3, 4, 5, 6, and 7. Along the x-axis, I'm going to break things up. I've got pi over 2. I've got 3 pi over 4. I've got pi. I've got 5 pi over 4. And I have 3 pi over 2. All right, and so putting this all together, what's one cycle? Putting it in red, I've got pi over 2 is all the way up at 7. 3 pi over 4 takes us through the equilibrium 3. Okay, make sure I graph that 1, 2, 3. Yep. All right. Pi is at -1. 5 pi over 4 is back at the equilibrium. And 3 pi over 2 is back at 7. So here is one cycle, all right, of our graph, the 4 cosine of 2 times x minus pi over 2 plus 3. If we wanted more, right, it would look like we would just keep breaking things down into pi. Looks like pi, everything's broken down into pi over 4s. So I think the next one would be 7 pi over 4, and then we would hit 2 pi, and then we would hit, I think, 9 pi over 4, and all this action would just keep repeating itself. So 7 pi over 4 would be here, 2 pi would be here, here, and here. So there would be another cycle if I had to do that. Of course, we could have done it backwards this way. So there's pi over 4, 0, negative pi over 4, negative pi over 2, and we could have just continued on in this fashion, right? So boom, boom, and boom. Okay, so but there we got at least one good cycle, and then we can just continue it on because we do know it goes on forever. Okay, so that's how you basically do that. Again, I think in some videos I'll share with you with somebody else doing it, they actually just manipulate the picture, and if you understand it, that's great. But for me, just having that raw data and just manipulating the data, it's like almost a no-brainer. It gives you exactly how you should be scaling your x-axis, exactly how you should be scaling your y-axis. Oh, and one last thing, here's our equilibrium, right? Y equals to 3, and you do see that the wave is 4 above it and 4 below it, right? So we're bouncing back and forth from that, what technically is an average value. So we know we're bouncing back and forth between -1 and 7, so on average, we're about 3, right? As a matter of fact, the average of 7 and -1 is, in fact, is 3. Okay, so there you have it. We'll do a couple more, but I'll do one separately in each video since there's so much going on. So a couple more videos of this coming soon.